Hello everyone, good evening. A warm welcome to all of you from ForceArk Academy. Thank you for joining today's webinar. In this session, we will be discussing an exciting and essential topic for every QA and developer. Automation testing, how it works, why it matters, and how to get started. Whether you are new to automation or looking to sharpen your skills with tools like Selenium and Cucumber, this session will give you a clear understanding of the concepts, tools, and real world use cases, especially in the platform like Salesforce and Communication Cloud. So let's begin today's session and dive into the world of smart, scalable, and reliable automation testing. So now let's see what will be the today's agenda. We will see why automation, what is automation, what are the tools that are available for automation, what is actually the Selenium and Cucumber, what mainly the setup and prerequisites are required for this particular automation testing, and we will see a little bit about the Salesforce Cloud's overview also. So what is automation testing? Automation testing is a software testing technique where test cases are executed automatically using tools and scripts like Selenium without manual intervention. So it replaces the repetitive work of clicking through UIs, mean to say user interfaces, or re-entering data with the code that does it consistently and quickly. So this approach is particularly effective for repetitive or high volume testing, such as regression testing, where the same functionalities need to be tested again and again with every new release. So it's ideal for stable features. For example, in Salesforce applications, once components like login or the form validations or record creation are stable, they can be automated to ensure consistent behavior across every releases. This automation testing is the one which also speeds up the testing cycle, which improves test coverage and reduces the chances of human error. All of which help maintain high software quality, especially in large enterprise systems. Now let's see now let's see why automation testing. The primary reason of automation lies in its ability to enhance speed and efficiency, which actually significantly lowers both testing time and costs. Once test scripts are created, they can be easily reused with minimal modifications. Automation also identifies defects early in the development lifecycle, so which is crucial for maintaining quality while enabling the faster release in agile or CI/CD. I mean to say continuous integration and continuous development and environments. This is particularly important for large systems like Salesforce, where interconnected flows exist, and automation ensures that essential business parts are consistently tested. Now that we understand what automation testing is, let's look at why it's so valuable. The biggest advantage of automation is the combination of speed and efficiency. Once you write your test scripts, you can run them any number of times across different builds, environments, or datasets with minimal efforts. This directly leads to reduced testing time and cost, especially when compared to manual testing that takes hours or days to repeat the same tests. Automation also enables us to catch defect early in the development life cycle, and it often within minutes after a code commit, which is crucial in agile and dev workflows. In fast-paced environments like agile or CI/CD, where code is released frequently, automated test can be triggered automatically on every push or merge. This helps to ensure that only quality code reaches to the productions. It becomes even more critical in larger systems like Salesforce, where multiple components and business flows are interconnected. Automation helps to ensure that all business critical paths, such as lead conversion, code creation, or order submission, are tested with every release without relying on manual testers to do it over and over again. Now, let's understand when to automate. We mainly automate when the tests are repetitive or the stable test cases. We have some business critical flows. There are some regression tests are required. And the fourth one is the when there are some data driven scenarios. So to understand this, let's see this that automation is not for every test cases or every use cases which are available. For example, if there are some unstable user interfaces or some one-time validation is required or very small task which is not an important, then that should not be automated. Automation of such tasks takes a lot of time and eh, that is not much use of it. So ideal candidates for automations are those that don't change often, like there are login flows, some checkout processes, and some data validations. Also, if the particular flows are business critical, then it should be automated. If a test case is used often or on multiple data sets or browser, automation actually adds a value. Salesforce offers a wide range of cloud products, each tailored for specific business functions. So let's go through some of the major ones. Let's look into the Sales Cloud. Sales Cloud is the core CRM, I mean to say customer relationship management type of product designed for sales team, and it helps to manage the leads, track opportunities, and forecast revenue and automate sales workflows. It's what most companies start with when they adopt Salesforce. Service Cloud. It is focused on customer support and case management. It includes features like knowledge base, omni-channel routing, chatbots, and integration with call centers. This is ideal for the customer service teams to resolve issues faster and improve satisfaction. Experience Cloud. It allows organizations to build customer-facing portals, partner communities, and internal collaboration sites. For example, a telecom company might build a customer self-service portal to check their plan, raise tickets, or make payments. Marketing Cloud. It is a powerful marketing automation platform. It supports personalized campaigns across email, SMS, social media, and even web. It widely used for customer segmentation, journey building, and campaign analysis. Commerce Cloud. It is Salesforce answer to e-commerce. It enables businesses to build scalable online stores, manage catalogs, and create personalized shopping journeys for both B2B and B2C customers. And finally, we have Communication Cloud, which is our focus area today. I mean, we will be taking the use case of the Communication Cloud. It's specially built for telecom, media, and technology industries. It was previously known as Velocity, and therefore industry and that provides industry-specific data models, product catalogs, CPQ, which is configure, price, and quote, and orchestration tools. It helps to telecom to providers to manage product configurations, customer orders, and billing flows more efficiently. So, depending on your business domain, Salesforce provides specialized clouds that can work independently or together as an integrated platform. So, In automation, we have the number of tools that are available. Different tools are used at different layers. So here if you see, for user interface testing, mainly Selenium, Cypress, and Playwright is used. For BDD tools, generally Cucumber helps to map scenarios to code using Gherkin. For API testing, mostly REST, Assure, and Postman is used. And tools like Jenkins or GitHub Actions automate builds and testing, and that helps into the CI/CD integration also. We can use Extend Report, Allure Report, or TestNG for reporting in the automations. Selenium and Cucumber overview. Now, let's understand the role of these two powerful tools in automation testing strategy. Selenium is widely used browser automation tool. It allows us to simulate user actions on web applications, like clicking buttons, entering text in input fields, selecting from drop-downs, etc. It supports multiple browsers like Chrome, Firefox, Edge, and can be written in languages like Java, Python, and JavaScript. On the other hand, Cucumber is a behavioral driven development framework, which is also known as BDD framework. It uses a plain English like syntax, which is called Gherkin, to define test scenarios. This makes test cases readable and understandable by business stakeholders, developers, and testers. When we combine Selenium and Cucumber, we get the best of both the worlds, like readable, which is used for non-technical people can read and validate test cases. Second is executable. Each line in the feature file maps to backend code that performs browser actions using Selenium. So this separation also improves maintenance and collaboration. Let's take one example for communication cloud scenario. Let's say we want to automate the test for create code for broadband process in Salesforce communication cloud. So we can create the feature file and step definition files for the same, which we'll see later. And this approach will especially useful in complex platforms like Salesforce Communication Cloud, where business logic, product configuration, and customer journeys are highly customizable. With automation, you can reduce the testing effort and ensure repeatable, reliable results during every release. So before jumping into the automation scripting, there are few essential tools that you will need to set up your environment. Let me walk you through them. Like the first one is Java JDK, in which Selenium and Cucumber are usually written in Java. So you will need to install the Java development kit, which is JDK. Version 11 or the later, which is mainly recommended, where because it's widely supported and it is stable also. Once you install this JDK, after that you need to configure your Java home environment variable correctly after the installation. Eclipse IDE, which is IDE stands for Integrated Development Environment. So this is your coding workspace where Eclipse is a widely used IDE for Java and it integrates well with Maven and Cucumber plugins. You can create Maven projects, run tests directly, and manage code with ease here. Maven. Maven helps you manage project dependency, especially Selenium, Cucumber, uh, JUnit or TestNG libraries. Instead of downloading jar files manually, which actually we were doing priorly, but now Maven uses the pom.xml file to pull and manage all required libraries automatically. So we just need to add the dependency in the pom.xml file, and all the required jar files are downloaded automatically, which we will see later when we see the Maven configurations. Git. Git is optional but recommended. Like, while not mandatory for local testing, but it helps to manage your code version history. It's essential if you're working in a team or using CI/CD tools like Jenkins or GitHub Actions. Browser versions or browser drivers. To run your Selenium test on a browser, you need browser-specific web drivers. For example, for Chrome, you may need Chrome driver. For Firefox, you need Gecko driver. And the web driver version should always match your browser version to avoid compatibility issues. Once these are installed and configured, you are ready to begin writing your first automated test with Selenium and Cucumber. A proper setup ensures stability and avoids unexpected runtime errors. So let's now walk through the installation of the Eclipse IDE, which is the backbone for your automation project development. So you first need to go through the official website of eclipse.org downloads, which you can type in the Google search box, and you can get through the links. After going to the links, choose the package Eclipse IDE for your Java developers. And this version comes with all the code tools you need for Java-based automation. After downloading the installer, you need to run it and choose the Java Developer Edition when prompted. The installation is straightforward and you just follow the instruction which comes on screen. Once installed, launch Eclipse. On the first run, it will ask for a workspace. This is the folder where all your projects will be saved. You can keep the default or choose a custom location where you want to keep your projects. So after setup, you can install useful plugins from Eclipse Marketplace. Here in this snapshot, it shows that after installing the Eclipse and giving the workspace details, this is how your Eclipse looks. Cucumber Eclipse plugin for editing and highlighting feature files also you need to install from the marketplace. Maven integration with these Eclipse is usually pre-installed, but you need to verify by checking pom.xml support. And to install plugins, you just need to go to the help in this screenshot. If you see, there is help option in the bar. You just click on that Eclipse Marketplace, search and install. So here in the first picture, you will see that in the Eclipse IDE launcher, you need to give the path for your Eclipse workspace, which is the one in which you can store your project. So you can set your path and click on the launch button. Once you click on the launch, you can see the screen of the Eclipse, which we have seen in the last screenshot. After opening that, you can go to the marketplace. So for that, you need to go to the help and launch marketplace. There you will have the details for the plugins that you can install. So you just need to give the name of your plugin and search it. It will come up and you just need to install it. It's a simple, straightforward step. So here in the second snapshot, it gives the Cucumber plugin, which you can install and save. Once Eclipse is installed and ready, the first step is to create a Maven project, which will manage your test framework structure and dependencies efficiently. So you need to go to the file tab in the Eclipse and then go to New and Maven project. On the dialog screen appears, and from there you need to create a simple project or any archetype, which will give you the Java structure to begin with. Now, once you can select the archetype, it will give you the prompt of the screen, which is in the snapshot as a new Maven project. In that, you need to enter the group ID and the artifact ID. Group ID is usually the domain style like name or the company name. Usually people gives, like if we give ForceArk Academy, and artifact ID is your the project name. So Maven will generate the basic folder structure for it, and Maven will automatically create the folder structure. So once you have created a Maven project, in that you will have a pom.xml file, which is the heart of the Maven project, in which you will give all the dependency details. So once you add all your dependency, you need to save the pom.xml file, and Maven will automatically download the required libraries and it will add to your build path. Here in this snapshot, you can see that all the dependencies which are required, like for Cucumber or the JUnit and the Selenium, that are added. And there may be the few libraries which more are required according to your project requirements, or if you are doing it with any report integration or so. So now you can start creating your feature files and step definitions and test runners files. This Maven setup gives you project a scalable and maintainable structure, which is especially important in enterprise automation projects like Salesforce Communication Cloud. So here is how your Maven project structure will actually look like. The project one is your main Maven project root directory, and all your code, any resources or configuration files or any dependencies lie in this. The main.java source file folder is the one where you put your core utility code and not the test code. The main resources file are the one which contains some configuration files. The test Java contains mainly your step definitions for your Cucumber feature files. And the resources one, which holds your Cucumber feature file, which is written in the Gherkin language. You can also test data files like some of the Excel or CSV file while doing the test execution. Here GRE system library, it indicates that what is the Java version is linked to this project, and you can update it to the Java 11 plus for modern frameworks if required. Target folder is also automatically generated folder for building the project, which sometimes contains some of the compiled class files or the reports that we generate, or say there are some output artifacts or the snapshots that are required, that which we mainly store in the target folder. And the pom.xml file, the central configuration file for the Maven project, which mainly defines all the dependencies like for Selenium, Cucumber, and WebDriver Manager, which we have seen. It can also have some build plugins like project version name and group ID, some test runners files, and some report configurations, etc. So this structure is created automatically when you make a Maven project, and it actually helps you organize your automation code cleanly and separating utilities from the test logic and test data files. So this approach is ideal for Selenium and Cucumber plus TestNG or JUnit based frameworks, and it is widely used in enterprise grade automation, including Salesforce projects. Before we implement all this and show you how practically it is done, which we'll see in our next webinar, let's understand how this feature file looks. So let's walk through this feature file. A business readable automation scenario is written in Gherkin language, which is used by Cucumber. Here the feature file is titled as the create broadband code. This describes what business process we are validating. In our case, it's the code creation workflow in Salesforce Communication Cloud, commonly used in telecom for offering broadband services. The scenario line defines a specific test case under that feature. The goal mainly, verify that a user can create a code for a 100 Mbps broadband plan. Now let's break down each step. Given the user is logged into Salesforce, this is our precondition. The test assumes that the user has already logged in using valid credentials. Selenium will handle login via UI automation. For example, entering username and password and clicking on the login button. When the user navigates to the code section, the test will simulate navigation, typically by clicking the tab or menu items to reach to the code page, and clicks on the new code. This action opens the code creation form, triggering models or input wizards that Communication Cloud uses, Velocity CPQ components mainly. Next is and selects broadband plan 100 Mbps. This step interacts with the product catalog components, selecting a telecom product using dynamic dropdowns or guided selling flows, and fields in customer details. Here, form fields like customer name, address, contact information, or account ID are filled in. This might also include selecting an existing account via lookup, and submits the code. The form is submitted by clicking a button like submit or save. Selenium verifies that the submission was successful and the page updates. And last but not the least, the step is then the code should be created successfully. Finally, we assert the expected outcome, usually by checking if success message appears or if the code appears in the list with a generated code ID. This readable format helps business users, testers, and developers all stay aligned. While the scenario reads like plain English, it is linked to Java-based step definition and executed by Selenium in the background. This is how we bring test clarity and traceability to complex Salesforce flows by turning business steps into executable automated tests. Let's take a look at the Java step definitions, how it looks. So here in the snapshot, you can see that how these step definitions are written. That connects our Gherkin scenario steps to actual Selenium actions. So this method corresponds to the Gherkin step. Here in the Gherkin step, when it is written that when the user navigates to the code section, it uses Selenium's find element method with by.linkTest, which is the section name, which is the locator, which looks like a hyperlink anchor tag that matches the exact text like codes, accounts, or the order. The string is a Cucumber parameter. It allows dynamic reusability of the step. So the same function works whether the user navigates to the codes, opportunities, or the account sections. This step mimics a real user clicking on a top or side tab inside the Salesforce user interface, usually in the Lightning interface. And this maps to the code and clicks on new code. It uses an XPath to locate a button element with exact visible text. Again, string is the dynamic, so allowing to reuse for the buttons like submit, next, save, or the cancel one. This is a flexible step for Salesforce or communication cloud models or page actions where buttons often appear in wizards or side panels. This step definitions makes the test modular and scalable. Instead of writing new code for every single button or section, you are writing general purpose function that plug into any Gherkin scenario. This approach also improves reliability, maintenance, and collaboration. Testers can write or modify feature files without touching Java code as long as the step structure is consistent. Here in this step, it shows that Gherkin step is a triggers which has the matching step definition method which gets executed, and the Selenium is the action on the browser which gets happened. This diagram mainly perfectly illustrates the flow of text test execution in Selenium Cucumber framework, especially useful for demonstrating how business related and reliable tests are connected to the real automation. Now, what is that are the test runners files and how this feature file is created, how this step definition file is created, and how all this test automation works. We will see it on our practical implementation in our next webinar. So thank you for attending today's session, and we will be very happy to see you in our future sessions.